Hi, my name is Sebastian and I'm going to be your instructor in this tutorial. This tutorial is about DALI in combination with Niagara or Emalytics. But what is the difference between Niagara and Emalytics? Phoenix Contact extended the Niagara framework with software and hardware extra functionalities and calls this solution Emalytics. Here we see the agenda. First of all, we will talk about what kind of customers we target with this tutorial. Then we will talk about the motivation, what is DALI for, or when is it useful for us in a project. Then we will go on with Emalytics DALI hardware and software. And last but not least, we will go on with the implementation of DALI in Emalytics automation, so the system integration of DALI. Who do we target? First of all interested parties, and we will give an overview about DALI. Then we will go on for planners and we'll talk about basics for the planning work. For system integrators, we will talk about how to getting started with our DALI functionalities. DALI stands for Digital Addressable Lighting Interface. It is a standardized communication protocol for lighting control systems developed jointly by several lighting equipment manufacturers. It allows lighting devices from different manufacturers to be connected to the same lighting control system. The DALI trademark is for certified products which have successfully completed the DALI 2 certification process, which is operated by the DALI Alliance and includes verification of test results. Let us talk about why we should use DALI in our projects. What we see here could be a floor of a building or maybe an area where we have up to 64 different lamps. We want to connect and we want to control. It doesn't matter if we have DALI 1 or DALI 2, we can connect those actors to our software and make a software wiring. With DALI 2, we got some extra functionalities, like sensors. We can integrate sensors for like switches, like presence sensors, but also sensors which are not directly for lighting, like temperature sensors or humidity sensors. We can also implement up to 16 groups. Let's say we have this floor and we want to create 8 different groups. Cost on this, we can reduce the wiring a lot. Instead of wiring each room to the controller, we can use those software groups. Another opportunity we will get by this is we can generate flexibility. So when we have a change in the room, maybe the walls will change, we can adapt our room to these new requirements. After we defined a group for a room switch. So when we have here a room switch at this place and we switch on and off this room with this group, we can also do multi-grouping. So we have one switch and with this switch we switch on more than just one room. Of course, in this example we switch on and off the whole floor, and this we could also do with the broadcast. In DALI we can also define up to 16 scenes per lamp. So we can imagine we go to the group of this room and we switch the room to scene 1. And those lamps we see here, they are defined for 60% brightness in scene 1. And those 4 here in the front, they are defined for 10% brightness within scene 1. So with the scene functionality, we can easily implement a scene button inside the room for, let's say, presentation mode or something like cinema mode. And when we push this button, yes, the scene goes to scene 1, the brightness adapts automatically, maybe also the shadings adapt automatically, and we will have a smarter room. So when we go out of the presentation mode, we would go to full brightness. And of course, in DALI, every lamp is dimmable. Because of that, we should consider if it's not cost efficient to implement a brightness sensor inside the room, to implement a constant light control or even a daylight control. Inside of DALI, meanwhile, we have a lot of multi-sensors to implement those functionalities cost efficient and save money for energy during the lifetime of the building. Of course, a big benefit of DALI is the wiring. Within this slide, we see a conventional wiring where we have to implement round about 13 digital outputs, 15 digital inputs, including switches and presence sensors, and also 14 analog inputs for humidity and temperature. Of course, this does not have something to do with the light functionality, but DALI can implement those sensors as well. And then the next question is if the project requires something like dimmable lights or scenes which are able, maybe at the beginning the customer is not interested, but maybe later on, and then it's not possible to implement those functions. And the sensors in a conventional wiring need an additional power supply. So how does it look like when we do it with DALI? Here we see a DALI wiring. The DALI itself has a low voltage, and we use a 5-wired cable to implement the DALI bus and also implementing the power supply for 230 or some other high voltage consumers. So we can use line, bus, star or tree topology, everything but no ring topology. So the wiring, at least it's very easy, and because of less cables we have less fire load, so easy. Let us come to the last USP of my slides. It's the failure detection. So when it's important for the project to detect if a sensor or actor is broken, we can see it in the DALI and connect an alarm to it. Let us now talk about the wiring in detail. First of all, we have a 2-wired cable for the bus protocol. Additionally, we have the power supply of the actors. To save installation costs, we should use one cable for both. But we should never use a GIST or a KNX cable, because when we have an event of a wiring fault, the high voltage is available on the bus line, and the bus line should withstand the high voltage. So we can just use a 5-wire NIM cable. Let us come to the length between the application controller and the control gears here. We have a DALI standard, and in this DALI standard we have defined the voltage and the current. Based on that, we can calculate the length of the cables, and for 0.5 square millimeters we have up to 100 meters. For 0.75 square millimeters we can come up to 150 meters, and for 1.5 square millimeters we can go up to 300 meters between the application controller and the control gears. On the DALI bus we have a DC voltage level between 9.5 and 22.5 voltage, but typically at 16 voltage DC. And the maximum voltage drop on the whole cable length should not go over 2 voltage. Let us now come to some rules of thumb. So one group should be reserved for each type of lamp, something like a ceiling lamp, wall lamp, pendant lamp. Then we should be aware of that a luminaire can have more than one address. As an example, an RGBW luminaire can have one address for red, one address for green, one address for blue, and another one for white. So we have 4 DALI addresses in just one single luminaire. Next thing we should consider is jointly controlled luminaires should be in the same DALI line. So it could cause problems when we use the absolute maximum of the DALI line, or we try to do it when we put some lamps or some luminaires into the first line and others into the second line, and we try to switch them at the same time. This could cause timing issues. We have a maximum load per DALI line about 250 milliamps, but down in the field mostly we don't have the perfect wiring. So we should consider a systemic load of 200 milliamps per line. Then we have to calculate for each ballast or for each control gear luminaire 2 milliamps. For the initial planning, we should not exceed 50 ballasts or 50 control gears. Because the power supply of a control gear is externally of a high voltage, it's easy in the DALI standard to maximize the milliampere consumption per control gear to 2 milliamps. Even when a sensor is externally power supplied with high voltage, we have this maximum consumption of 2 milliamps. But when it comes to a sensor which is powered over the DALI line, we need to look into the datasheet what the actual power consumption of the sensor is. But for a first rough planning, we can calculate with 12 milliamps per control device. We will now switch from the DALI basics to the Emalytics hardware and software. First of all, we see a short overview of our ILC2050BI building controller. So first of all, here's the controller, which has a managed switch with 2 network cards and 4 Ethernet ports directly here. We have a third network card here to configure the network addresses here, to configure also the switch configuration, and we can do the hardware commissioning, so we can see if the digital analog in and outputs are working or not. And this is over the web interface without any programming skills. The controller is modular and we can adapt 63 terminal blocks to the controller. Out of those 63 terminal blocks, 8 terminal blocks can be communication modules like M-Bus, like MP-Bus, like RS485, 422 and so on, or DALI lines. For more information, please check the link above. Like I already mentioned, we can connect up to 8 communication modules to the ILC2050. So also 8 DALI lines per controller. And the interesting thing, the DALI power is already integrated into those lines over our terminal blocks. So the first terminal block could be this one. It's called the IBIL DALI Power Pack. It's certified as a DALI 2 master with DALI power supply. It's single master capable, used to connect actuators, so we can't connect sensors to this DALI Power Pack module. But we can connect up to 3 more of those small modules which use the power supply of the first Power Pack module. And this small module is called IBIL DALI Pack module. So those 2 are not able to implement DALI 2 sensors, but DALI 2 actors. When it comes to DALI 2 sensors, we should choose the IBIL DALI Multi-Master Volume 2 Pack module, which is a certified DALI 2 master with DALI voltage supply and multi-master capable. So we can connect actuators and sensors. With October 2023, our software supports the following control gears and the control devices like mentioned here. Further information you will directly find in your workbench help. Just right here, or we go for Emalytics, manuals, and open the manual just right here. And we can search for the so-called DALI device types, let's say type number 202. And we can see here if the current version of Emalytics or our Niagara add-ons will support the required DALI functionality. For the light automation, we have the so-called Emalytics Room library. Inside this library, first of all, we see 3 sections: lighting, shading, temperature. The lighting section, here's the generic light control component. And this component is pretty easy. We just have one single component to do the complete light automation. So on the left hand side, we implement the sensors and set points. On the right hand side, we connect the actuators, and the whole configuration will happen inside this AX property sheet. We can switch the functionality of this component just with this drop down, and let's say make the configuration of a constant light control just right here. That our complete light automation is just in one component gives us a possibility to work pretty powerful with the so-called bulk deployment of Niagara. With this functionality, we can create templates and configure and enroll those templates over CSV, so over Excel. You will find more information in the help documents. We end the preview of the software with the Emalytics view functionality. Here we have the Emalytics view, which is on top of the Niagara framework. First of all, we have here a few buildings. We can also have a look about our energy management of the location right here. We can see the lights outside of the buildings. We can go inside a building into any floor. We see also here again the energy management of this very building. Let's go down into one floor and we see now here temperature, but what we are looking here for is the lights. And we here have a very nice overview, and we could also implement a few control panels just right here to set new set points to those rooms and floors. We will now start with the chapter which is especially for system integrators, and we will learn how to integrate a DALI system into Emalytics automation. In our floor example, we already talked about that we have some luminaires we want to group. We have some luminaires in this group we want to control over scenes. So when all those luminaires in this group go to scene 1, those luminaires go to 60%, those luminaires go to 10%. There are also some other stuff we can define per DALI standard, and all those configurations will not be stored inside the controller. They will be stored in the luminaires and the sensors itself. Because it is like that, we can choose the configuration tool we already know and worked in if we want. So here's an example. We can just connect a DALI mouse to our DALI line, so the DALI power is already implemented here, and we can connect our notebook to any kind of configuration tool and do the configuration as we know it since years. In this tutorial we learn how to implement the configuration with our Emalytics automation. So we can also do the configuration directly in Emalytics and without a DALI mouse. We will now start with the Emalytics automation workbench. We can also work with an external Niagara workbench and implement our Phoenix Contact Niagara add-ons to do so. So the first thing is we go to our ILC 2050 BI, to the driver section, and implement here a new Seismic SCAR.io network. Go inside, discover the terminal blocks which are available or connected to the controller. We implement them. They are now integrated and they are working. We see it in the status. And we now go back to the driver section and implement an Emalytics DALI 2 network. It's now kind of easy. It tells me no DALI terminal or defined, because this software needs to know out of which hardware it should go out into the field. So we choose the AX property sheet, and here we have the DALI network. We have a look inside, and here is the communication configuration. We also see the fold DALI terminal or so far null. We choose the component chooser and go to drivers, Sysmic, and here we have our DALI line, save, and we are now fine. What I did now is described also in the help documents. And here we have a quick start. Here we see how to add a network and much more. We now can open the DALI 2 network with a double click right here. And I will now do a discover. And here I have the possibility to do addressing. And I say I will do a totally new address. I will give a total new address to all devices. I will just give a new address to unaddressed devices, or I will do no new addressing at all. And I can define if it's for a control gear, for a control device, or for both. So for sensors and actors. Let us have a look to the control gears. The addresses we see here, they are randomly addressed to the devices. If our project only requires broadcast communication, we don't have to do the random addressing, but this will also give us some advantages. Let's say we just have the random addresses, implement them here. We just have the devices now implemented in our system. As soon as we do not implement the single data points here into this device, we just let it free. We don't have any license data points used, but we see if a communication is broken to an end device. We will now implement a configuration for a DALI line, for a floor, where we want to do single commands on single luminaires or on groups. We will open our control gears. We have to go into the room or into the floor that we see the lamps. And we now choose any kind of lamp here. And I choose the very first. And for DALI 2 lamps, I can use the identify mode. Then the lamp or the luminaire will start blinking. And for DALI 1 lamps, we can use the on and off command, which we can use over those two buttons here. So we just try it. You see in the background I have some luminaires installed. And here, this is my third lamp. I will go here, set address, set it to address number 3. I will go to the second one, switch it on. This will be my address number 6. And the third. This is my address number 2, so it's already okay. Just switch them off. This is my number 5. Number 4. Yep, already correct. This is my number 1. Set address to number 1. Fine. Now we can do the same thing for the sensors. And all sensors I know so far, they have a little LED implemented, and I can go to the sensor and push the identify button here. You see here also the on and off command. They are not able to push because yes, all DALI 2 devices, they have the identify. So sensors are just DALI 2. I can go over here and I now know this is my I will not do the readdressing right now. The addresses are okay for me in this case. So I directly give it a new name. And okay. We will now write the configuration into the luminaires with this button here. We now want to implement those devices into our database in the best way, in a correct order. This for we just make a second discover without addressing. We now drag and drop the devices into our database. So clean things up. I will do a short reorder here. Right click, reorder, put the sensor to the other sensors. It was address number 2, so it will be the third one here. And we also will switch off the lamps or the luminaires. And we will now go on with the configuration of the DALI properties. This for we can go to the AX property sheet to see the first option we have. We have here our devices, and here is a control gear, and inside this control gear I can set the configuration of this very device to say if it belongs to what kind of group, what kind of power level it will have on each scene, the dimming curve, the fade time, and so on. When we think about our DALI line, maybe all lamps in a group or all lamps in the whole line have the same or need to have the same configuration in some parts. This for we can go to the DALI network and we can choose any kind of group or even the broadcast and go back to the AX property sheet. Let's have a better overview here. We have the group and we can tell the group what kind of configuration all kind of devices should have in this group. A very useful property is also the agent address. Let's say we give a set point to this very group. The group itself doesn't talk in DALI, so we can define a leading agent address of this group. Let's say we have luminaire number 3, and this will talk for the whole group. So when we tell the group go to 30%, we read out this number, this address number, and we know where this luminaire is, and then we think, okay, the whole group must be at this power level. But before we can do the configuration over the groups, we have to tell each lamp to which group it belongs. And this for we can also use underneath the services the ProgramService. With the ProgramService you can multi-edit any properties of components, but you can also add some functionalities. First of all, we have to fill components into the batch editor we see here. This for we can use the functionality find objects and search for certain things out of our station. But we can also easily work with drag and drop. So let's say we want to configure our control gear number 2, 3, 5 and 6. We drag and drop them into the batch editor. What has to be mentioned is that every object which is inside the batch editor will be edited or will get a slot. So when we choose just 2 of them and we go for edit slots, we will edit all 4 components which are implemented into the batch editor. We now see a property config, and inside this property we can set the groups, we can also set the scenes, we can set the fade time. What should the luminaire do when the system has a failure, or what should the luminaire do when the DALI application controller does not send any command to the luminaire. When the configuration of the devices is due to our project requirements, we can push the OK button, and we see here the result took place in our system. So now we can go on with the next DALI group, and this for we clear this batch editor, pick the next devices, and we will go on. When we finished our DALI line, we go back into our DALI 2 network and we write the network configuration into the luminaires, because till now the configuration is inside the software here but not in the luminaires themselves. So let's have a look. When we go now to the AX property, we can have a look into the configured devices. So we configured device number 2, control gear number 2, and here we have the configuration, and here we see our configuration. So let us upload it into the control gears with the right network configuration command. We will now check if we can send a group command to group number 3. So here we have control gear group number 3. We will discover the power level set point here, and now we have the action What we see now is that we send a command, but we don't get any feedback. To change this, we have to go to the AX property sheet. I will work with this level here and open the AX property sheet right here to make a faster configuration. So when I have to multi-edit different groups, I can configure them all in just one view. So let's make a short overview. Here is my control gear group number 3, and the agent address will be number 3. I will save it. And now we see the correct power level we've just sent. Over the power level itself, we can set a new power level set point. But we have also other opportunities and other actions when we use the actions of the device itself, like the go to scene command. So if we have configured the scenes in this group, we could now also work with the scene command. To implement a smooth dimming curve to our luminaires, we should not try to implement the dimming curve into our application. In this case, we would send a lot of commands over the DALI line, and we have a serious load of data traffic in our serial communication. A much more efficient way would be to go now to our groups, and we would go to the configuration, and we would just change the fade rate and the fade time. As it seems, the configuration of this group here in our Emalytics is not the configuration of the luminaires themselves which are in the group. To update this, synchronize, we make an action read command and a refresh of the page. And now we see the correct grouping, because when we wouldn't mark this one and write a new configuration down to the group, the luminaires wouldn't listen to group 3 anymore. So let us configure fade time and fade rate. Here we see the definitions. When you have more interest into the topic, the fade time is the seconds how long the dimming curve will take, and the fade rate is about the steps per second, the smoothness of the dimming curve. I will define 90 seconds, 3 steps per second, save it, and now I will write the configuration down to the single group, and I will set a new set point to 100%. We can also go into the software to see what exactly happens here, and we see a very smooth dimming curve we've implemented. So when we have a constant light control, this will be very useful to implement a very smooth dimming curve. Let us now have a look how to configure a sensor and how to implement a constant light control. I will just switch the lights off. I will go to my DALI 2 network, and here I already implemented the Steinel HF360 sensor. I will go to the data points. I will make a discover, and I will drag and drop those data points into my database. First of all, I want to poll them all. So I selected all data points once and then made a change for all of them. Then I do the naming. For me, the light sensor and the occupancy sensor is clear. For the general purpose input number 2 and number 3, I will have a look into the documentation of the sensor itself. So here we see instance number 2 is for temperature and instance number 3 is for humidity. In the DALI standard, values are defined with a percentage value. Technically, this percentage value will be transmitted with a certain resolution. This resolution is different due to the sensor and due to the value. In your application, a light sensor you will normally need with a lux value and not in percentage. Because of that, we have to recalculate the percentage value and have to interpret it into the correct value. This raw data slot is for. So we choose all three, choose raw data, and here the resolution, the system reads it out from itself and calculates the real value, the raw value we will need for our application. For the temperature and the humidity, oh, here's a mistake. This will be the relative. This will be the relative humidity because it is in percentage. We have a scale. The scale we see inside the documentation. Just right here, temperature 0.1 and -5. So we choose the temperature, go for a linear conversion, 0.1 -5. Then we will have a look for the humidity. And here we see a scale of 0.5. The humidity is in percentage. And the temperature will be in degrees Celsius. And that's it. Okay, we now see those values. We have a relative humidity of 55%, 23 degrees and 134 lux in this room. And we have occupied with no movement status for the occupancy sensor. Next step is you can do any kind of structure here, and inside the structure I will implement a generic light control component. And this component, first of all, I will connect to sensors and actors. Therefore, I will link mark this very component. I will have a look for the sensor and I will link it to the light sensor right here. So the light sensor should be linked to the generic light control component, the output. And on the right hand side, I choose the brightness slot. Okay, the same for the occupancy sensor. Link it to the generic light control component, this output to the presense slot over here. We will now have a look for the control gear group number 3. And here we have the power level, and inside this power level we can set the set point for this group. We will make a right click and we will come from the generic light control with the output slot to the input of the power level. And now we see our dimming curve. Okay, now we have to configure the component. First of all, we want to have a constant light control. Then we will have a look for the constant light configuration. We want to have 500 lux and we have to configure the loop. This is very important. We set its execution time, let's say, to something like 3 seconds. All 3 seconds the loop will generate a new value. Then we have to implement something for a proportional constant, something like, let's say, 0.5, and for the integral constant we choose something like 1.3, but this depends due to your application. We will save it and we see how the controlled variable raises slowly to this set point, that we have a smooth dimming curve like we wanted it. Let us now talk about the opportunities we have with the bulk deployment mechanism of Niagara. An example when the bulk deployment is very useful for us is when we would like to do the configuration over Excel, or even we have a planner tool and inside this planner tool the informations are already given, which control gears belong to which groups, which scenes do we want to have, and so on. And of course, the goal should be that we copy the configuration from the previous planning into our Excel sheets. With this configuration opportunity, it could also make a lot of sense to take a bigger focus onto standardized projects and then creating standardized templates. Based on those standards we have now, we connect the planner tool to our Excel file, and then we will partwise generate our application automized from the planning tool. To transfer configurable tables to Excel, the first step we have to do is we have to create a template inside Niagara. Therefore, we can grab our instanced control gears, so our actors, but also our sensors, like this. We create a template. Let's go to the components. Maybe we don't want to make single controls here, so I just will delete this data point. I could go to the configuration and make some presettings right here. And then the important thing is the configuration. And here I have to implement all things I would like to configure inside Excel. If you are interested into more details of the templating mechanisms of Niagara, please feel free to contact us to participate our Emalytics trainings, where we have special video tutorials for that topic. And also you can go for Emalytics, manuals, and here we have the doc templates PDF document, where you find much more details about the templating mechanisms of Niagara. We will now generate the template with this Save button. When we now start from scratch and implementing all configurations over the bulk deployment, let us think about our control gears probably don't have a correct address. So first of all, we have to do the discover, make the random addressing, and then go into the room, make the correct addressing, and then we will go on with the configuration of the control gears themselves. And we now have to open our template sidebar, and here we have our control gear. We could also now export more than just one template to Excel. But let us start the easy way. We will export our configs. We will give it a name. Because I created this template as a user, I have to go to the Niagara user section. This is in Drive C. Supervisor, Workbench, User Home. So this is my user section. And you see this is the user I've been logged into. And here are templates. So here's our control gear. And here's also our DALI configuration. We will now open this Excel sheet. For each template we implemented into the Export Configs option. We now have one tab. As we just exported one single template, we can now enroll this very single template. First of all, we have to tell this Excel sheet where we want to enroll this template. Here we have an example. It will be driver/ and then the name of our network driver. To not make a mistake, I will just copy it. Here's now my device name. Let us again have a look inside our application, and here the device name is Control Gear 1 and so on. So I will just copy this, bring it to my Excel list. The display name is optional. The position, this is for the wire sheet, it's also optional. The unique device name is also optional. For more information, please have a look into the template manuals and into the bulk deployment. We can now define our configuration. For the minimum level, we have a default value of 33. So when we don't type in anything, the default value will take place. If you have questions for the correct configuration levels, you can have a look inside the user tips, or you can also have a look into the manual of the configuration. When we do the configuration of the groups, we have to make sure that we use the correct separators as given here in the example. So this control gear will now belong to group number 0, 1, 2, 3 and to group number 7. We will now also give percentage levels for the scenes. Plus we will adapt the fade time due to our first example. Something smooth like 90 seconds. We now created the whole configuration for all control gears. We will go copy this one because we just work in one single DALI line. Copy it here. And we now have 32 devices which we will implement in the next step. Of course, we could also implement control gears for more than just one single DALI line. I will now save this configuration. And we will now go to Emalytics Automation or Niagara. First of all, I will clean things up here. And now I will go to the services, template service, bulk deploy from Excel. We now see that all templates are enrolled. We will have a look inside the DALI network. First of all, we see that the devices are disabled. This we can change over the program service like we already learned. And now we have the configuration in the software, but not in the ballasts, not in the control gears. So we have to use the right network config button now. The opportunities we have right now is these templates, they are versioned. So we have enrolled them in a certain version. We could make any kind of changes right here. Then we could go to the template service and make an update from the templates which has been changed. We could also do configuration changes inside Excel and use the update configs from Excel button over here. We are now coming to the end of this tutorial. If you like the video, I would appreciate a thumbs up. If you are interested into our solution, we would be pleased to hear from you via the common sales channels. If you are interested in installing Emalytics, you can find the appropriate video tutorial link here. Thank you for your time and hope to see you.